Hi guys, today we're going to try an integration B problem. Okay, so we're trying to find the integral from -1 to 1 of the max of either 0 or the square root of 1 minus x squared minus a half dx. Okay, so first off, let's find when this is less than 0. So this is less than 0, 1 minus x squared minus 1 half is less than 0, is when 1 minus x squared is less than 1 half, or square root of 1 minus x squared is less than 1 half. We know 1 minus x squared has to be greater than 0. So where 1 minus x squared is less than a quarter. Right? Yeah. So negative x squared is less than negative 3/4. So x squared is greater than 3/4. So x is greater than root 3 over 2. So from, oh, but really x, it mirrors. So when x is greater than or is greater than, or when x is less than root 3 over 2, is less than negative root 3 over 2. Okay, so if we look at this, it's going to look like, so from here to here, which is, this is root 3 over 2, and then this is negative root 3 over 2, and then it's going to do like this weird thing there. Okay, so now we need to solve the integral here, this area here, and this area here. We see that it's going to be the same since x is mirrored. So we just need to find the integral from root 3 over 2 to 1 of square root of 1 minus x squared minus 1 half dx. How do we find the square root of 1 minus x squared? Well, that's just going to be a semicircle. So if we can split this up into the integral of this here and then the integral of this here. The integral of 1 minus this is going to be a semicircle. Well, if we look at this geometrically, it's going to be like a semicircle, like this, and then move it downwards, so like this. Oh, I just found where it's less than 0. So this is where we don't want to count. So we don't want to count that. So we just want to find this area here, this positive area here. How would I find that? I mean, of course, using an integral. So we know it's the area from negative root 3 over 2 to positive root 3 over 2 of the square root of 1 minus x squared minus a half. But I know this is a circle, and then we can find the area of the circle, but it's not the bounds of a circle. So how do we find that integral without doing that? It's the square root of 1 minus x squared. Square root of 1 minus x squared. Square root of 1 minus x squared. You can't use u sub. Can't use integration by parts. Can't use partial fractions. What other strategies? Trig substitution, maybe? I think it's a squared minus b squared, but this doesn't like the correct form. That might have to be in the denominator. And the area that it takes up isn't uniform, so we can't say by moving it down one half, we're moving it down halfway, so it's half of the area. It's just not how that works. Um, hmm. Well, let me draw a more accurate visual representation. We have a circle here, and then it's going to look like, or we have, sorry, the grid here, and it's going to look like, probably like this, and then just erase this part. And we want to disregard this section. Only want to regard this section. Huh. Hmm. So right now we're trying to find the integral of the square root of 1 minus x squared dx. Maybe we should use polar. Let x equal cosine of x, cosine of theta. Then dx, no, we can't use polar. That's only with double integrals. Um, oh. I'm not sure. I really don't know. I'm gonna look at the answer provided and we'll see if we could reason it out. Okay, this was the solution. Pi over 3 minus root 3 over 4. I did not get a... No, I didn't even guess anything. If you were to look at this 1/2 part, if I were to have done this, we'd have gotten minus 1/2 x, and then from root 3 over 2 to negative root 3 over 2. So we'd have just gotten negative 1/2 x, negative 1/2 root 3 over 2, minus 1/2 root 3 over 2. Wait a second. Oh, minus, I guess just minus plus, so it would have been root 3 over 2 plus negative root 3 over 2 minus root 3 over 2, or root 3 over 4, root 3 over 4, so then I've gotten root 3 over 4. I don't really know. What I should have gotten would have been root 3 over 2, but it should be root 3 over 4. I'm not sure how I would have gotten pi over 3 for this. It doesn't give a solution, so I don't really know. If any of you guys know how to do it, please tell me in the comments, but I'm not sure. Thank you for watching. I'll see you guys tomorrow, and goodbye.